Hello everyone. Next topic is eliminating epsilon transitions. So we have seen in the last video NFA with epsilon. So in some cases we may need to move from one state to another state without taking any input. At that case you're going with NFA with epsilon. But as we discussed, NFA with epsilon and NFA will not be encouraged in real world applications. So why? Because in the real world applications, if I give some input, it should justify whether it is accepted or rejected, like by choosing only exact one destination but not multiple destinations, right? Why? Because it's not a human being to decide on its own which path I should take, right? So finally, whatever it may be, whether it is NFA with epsilon or NFA, finally it should be converted into DFA only. But our convenience, for our convenience, we're going with NFA or NFA with epsilon, right? So so for that conversion, what we need, if you are drawing or if you are writing NFA with epsilon, for that conversion process, we are following this process. So first NFA with epsilon to NFA, then from this you can construct DFA. This already we have seen from NFA to DFA how to construct, how to change NFA to DFA. Already we have discussed in the previous videos. Now if I have NFA with epsilon, if that NFA is containing epsilon, how to remove that epsilon transitions? If I remove this epsilon transitions, what it will become? It will become NFA, right? So from that you can easily construct DFA. So for that conversion process, we're going to remove this epsilon transitions. So that we are saying this. So here we have some process for that elimination. So first, these are the different steps. So find out all the epsilon transitions from each state from Q. So in the previous video, we have seen how to find out epsilon closure. So finding epsilon transitions in the sense, just finding epsilon closure for all the states. For example, if I have three states in the diagram, A, B, C, you need to find out epsilon closure for A, B, as well as C also. And the next step is then delta bar transitions. So this is delta dash transition can be obtained. So what is meant by delta dash? So if I take delta as transition in NFA with epsilon, delta bar is nothing but the transitions in NFA. That means after removing epsilon, whatever the transitions you are getting, that you're taking it as delta dash. So to find this delta dash transitions, we have one formula. So this is the formula. So you need to apply this formula for each state, on each input. For example, we have two states here, Q1 and Q2, and we have two inputs here, A comma B. Then how many delta bar transitions we'll get? Q1 on A and B, Q2 on A and B. So totally we need to get 4 transitions here. So like that, for each state on each input, you're going to find this delta bar transition. So the formula for this delta bar transitions is this one. So epsilon closure of delta cap of Q comma epsilon. So this is nothing but you can replace this with epsilon closure of Q. So epsilon closure of Q, what we are calling it as just delta cap of Q comma epsilon on each input. So this is nothing but the whatever the input you are taking, just copy as it is. And this Q is nothing but the state on which you're calculating the new transition. So we need to repeat the step for all the states on each input symbol. And then finally, we will get the updated transitions. For that updated transitions, draw a transition table and draw the diagram for that transition table. Then we will get the NFA without epsilons, right? So now we'll see one example for this. So convert the given NFA with epsilon to NFA without epsilon. right? This is without epsilon. So in this diagram, so this is the problem for 0 star, 1 star, 2 star. So that means how many states we have? 3 states, Q0, Q1, Q2. And how many inputs we have? 0, 1, 2. That means you need to remove this epsilon here. What is the first step in the previous process? So the first step is finding epsilon closure for all the states. So we have 3 states here. Find out epsilon closure for all the states. So how to find out epsilon closure? So epsilon closure means the set of all the all the reachable states on input epsilon. So if you provide the input epsilon, there it can move, right? So in the last previous video, we have seen this epsilon closure of Q naught. So by default, that state will come here. So that state in the sense Q naught. But this Q naught, if I give the input epsilon, where it is going? Q1. So I can stop the process there itself, but Q1 on epsilon, again it is going to Q2, then I should consider Q2 also. So epsilon closure of Q0 is Q0, Q1, Q2. Then epsilon closure of Q1 means itself, that's it, that state itself, that means Q1. And if I give epsilon to Q1, where it is going? Q2. So I should add Q2 here. So epsilon closure of Q1 is Q1 and Q2. And coming to Q2, just Q2 itself, but if I give epsilon to Q2, it is not going anywhere. So that's why it is simple Q2 only. So now first step is over, and the second step is finding updated transitions. So updated transitions in the sense how many updated transitions we have here. So how many states we have? Q0, Q1, Q2, 3 states, and how many input symbols we have? 0, 1, 2. So for Q0 on 0, on 1, on 2. For Q1 also on 0, on 1, on 2. For Q2 also on 0, on 1, on 2. So 3 threes are totally, we need to find out 9 updated transitions. So to find out updated transitions, what is the formula? This is the formula. So first time I'm taking Q naught on 0. So epsilon closure of delta cap of. So this is Q naught. So as it is, I'm taking Q naught and epsilon. Then what is the input you're taking here? 0, right? So instead of this, you can replace it with epsilon closure of Q naught. Then the input is as it is 0. So what is epsilon closure of Q naught? Already we find out, right? So what is this? Q naught, Q1, Q2. And what is the input you're giving? 0. Now, on these 3 inputs, 0. That means you need to perform union here. So, delta of Q naught on 0, union Q1 on 0, union Q2 on 0. So, Q naught on 0, where it is going? Q naught on 0, it is going to Q naught itself. So, Q naught is 0, it is going to Q naught itself. Union Q1 on 0. So, Q1 on 0, nothing. There is nothing, no state. So, I need to write 5. And Q2 on 0 also nothing, so I'm just writing 5. So if I perform union for all these, what I'll get? Again, I'll get Q0 only. So now epsilon closure of Q0, what is epsilon closure of Q0? Q0, Q1, Q2. So this is the one updated transition. So Q0 on 0, where it is going in the new diagram, it is going to 3 states, that is Q0, Q1 and Q2. So it is going to 3 states here. So like this, you need to check, you need to find out all the updated transitions. So next one is Q naught on 1, similar process. So here Q naught, same Q naught on epsilon and the input is 1. So I can replace it with epsilon closure of Q naught and 1. So what is epsilon closure of Q naught? Q naught, Q1, Q2 on 1. Then you need to perform union here. So if I perform union, what I'm getting again? Epsilon closure of Q1 I'm getting. What is epsilon closure of Q1? Just Q1 and Q2. So like that Q0 and Q2, so Q dot on 2 input. So this is the output. And then Q1 on 0, Q1 on 1, Q1 on 2. Then Q2 on 0, Q2 on 1, Q2 on 2. So now all 9 transitions are over, 9 updated transitions. So these are the 9 updated transitions we got. So Q0 on 0, Q0 on 1, Q0 on 2. These are the results. So Q1 on 0, Q1 on 1, Q2, Q1 on 2. So these are the results. Q2 on 0, Q2 on 1, Q2 on 2. These are the results. So for these results, so I'm just drawing one transition table. So for this transition table, I'm drawing a diagram here. So this is the diagram, final diagram. NFA without any epsilons. So this is NFA only, it's not DFA. So in the question, if they ask for DFA, again you need to convert this NFA into DFA also. So why I'm calling this NFA in the sense, see, you can check. So here on 0 it is going to Q0 as well as it is going to Q1 also, right? So coming to final state, see, you can check here. Here Q1, Q2, Q0 are the final states because epsilon closure of Q0, epsilon closure of Q1 and epsilon closure of Q2 contains the state Q2, right? So that means, what is the meaning of this? In the given diagram, Q2 is the final state, but this Q2 is occurring in epsilon closure of Q0 as well as Q1 as well as Q2 also. So wherever you get this Q2, all these states will become final states in the updated diagram. So that's why in the final diagram, you're taking all these three states as final state. So this is the conversion or removing epsilon transitions in the given diagram, or converting NFA with epsilon to NFA. So for this, we have one homework problem. So if you want, you can practice this. So Q0 on B, it is going to Q0, with epsilon Q1, then with epsilon it is going to Q2. So what is the first process? First step is finding epsilon closures for all the states. We have three states here, Q0, Q1, Q2. Then finding updated transitions. So how updated transitions in the sense, for all the states you need to update. So Q1, Q0, Q1, Q2. And how many inputs we have? We have only 2 inputs here. So 3 to the 6 updated transitions will get. So find out all the 6 updated transitions using that formula. After finding, draw the table. So for the table, draw the diagram. So which is nothing but the NFA without epsilon. So thank you.